Morning everyone. In today's class we'll start the equilibrium concentration of Schottky defect. In the equilibrium concentration of Schottky defect we'll just deal with the what you can say how we can create the Schottky imperfection that we'll see here. So we'll just start with the equilibrium concentration of Schottky defect now. So equilibrium, see, we just start with this equilibrium concentration of Schottky defect. Right, so we'll particularly we deal with the ionic crystal. There are two things here. Either the Schottky defect is will be possible in ionic or the metal. So in today's class we'll just discuss about the ionic, right? Very briefly we'll just discuss about ionic. If you have any doubt regarding this ionic crystal or what you can say metal, that we'll definitely discuss in this today's session. So before starting this metal or ionic crystal, one should be very much clear with the theoretical part, right? What you have to write in the examination, consider the ideal crystal. Let us consider there is an ideal crystal. So in practice we'll not have ideal crystal, but for our discussion part we'll just consider the ideal crystal. So let us consider ideal crystal which contains n number of atoms, n atoms, capital N number of atoms, and if EV, you can write EV, right? This is EV. EV is the free energy required to create Schottky defect. So we are actually creating this Schottky defect. So it requires some amount of energy. So let us consider E suffix V is the free energy required to create Schottky defect. So, right? If this is the case for what you can say ionic crystal. This is the case for ionic and metal. You will have differences. What is the difference? So whatever EV have considered, that is for ionic metal, and for ionic simply I will just write it down as ES. That is only the difference you will find that. This is only for comparatively varying the different types of substances coming into consideration. Here what we will do is that the next important aspect is that in the today's session we'll just discuss about the what you can say a general talk about the Schottky imperfection or Schottky defect, both in the ionic and metal. So in the examination he will ask you either metal or ionic. So regarding the metal, only the difference you find. See, in metal you will find a difference. What is that difference? You will find that we'll just take it as EV. We'll just call that as E suffix V, and for ionic crystal we'll just take it as ES. So for if in the examination will ask you if ionic crystal, you have to replace this E with ES and EV for metal. Now in today's session, right, we'll comparatively we'll study this. Already this has been done in the previous classes. So in this today's class we'll just consider the probability concept. Then again we are consider the probability concept. So once we will consider the probability concept. In that probability concept, what we'll discuss is that we'll use the permutation and combination. So the probable value of the what you can say creating a Schottky defect. So mathematically how it look like. So how many total number of atoms are there? N. So we will n factorial divided by how many Schottky atoms? Small n factorial. So what is remaining here? Capital N minus small n. So now this is the what you can say, the probability concept that we'll use for just a minute, this is n actually, right? So this is for which one? This is we are considering it for metal, right? Metallic crystal, we'll just say metal. For metals, this is the case of probability concept, and for ionic crystal, same. See, comparative study we are doing here. Consider the probability concept. Here for ionic crystal, the same thing. P is equal to capital N factorial by small n factorial into capital N minus small n factorial, right? This will be square. And this is for which one? Ionic crystal. We talk about ionic crystal. So now this is the case for ionic crystal. So I think that you got a clear idea, right? That same these two are of which defect we are talking about? Schottky, right? We discuss about the Schottky defect. So in the examination, if we ask you the equilibrium concentration of metals, means you have to write this probability concept will be varying. This is mathematical term that will be varying for the metal. It will be P is equal to n factorial by small n factorial into capital N minus small n factorial, right? So for the ionic crystal, you will find that capital N factorial by small n factorial into n minus n factorial whole square. So probability concept will vary for metal and also for the ionic crystal. So the part which is here, the energy part we are using here, we will just write it down here EV, and the energy part we will just write for the ionic crystal is ES. So this is only the comparative study regarding the Schottky defect. So in the examination, if he ask you regarding the metal, then the probability concept that you have to take into consideration is this factor, and the next one the probability concept that you have to take for the ionic crystal. So now I think that you will have you are having very clear idea regarding the equilibrium concentration of Schottky defect. If it is ionic, what is the probability concept mathematically you have to write, and what is the probability concept for the metal. So it has been very easy for you to understand it. So now what we will do is that now see, now we will just go for the next part. Now next one is we'll just go for mathematical mathematical expression. So first we'll go for metal. See, first of all we just go for the metal. So we'll just go for the metal here. You'll what we'll take here is that first we'll go for the metal part. So for metal, again what we will use entropy. So why we are using entropy here? So we are creating a disorderness in the crystal. So this is what we will call disturbance which is created in the metal or ionic crystal. So disorderness in the system is your entropy. Now this I think that everybody is having idea about the entropy. So now mathematically this is theoretical definition. Yeah, this is a theoretical definition. Theoretical definition is disorderness in the system. This is called theoretical definition, and how you will write it mathematically. So that mathematical part we'll just discuss here. So here see the mathematical. So mathematical expression for entropy. Entropy mathematical form is what? See, mathematical form will be S is equal to K. K is some constant, Boltzmann constant, log P. Now this is the we'll just take this as equation number 1 if you go for a metal, and this is for we'll just take it at equation number 2. So clear everybody? So what we are trying to do here now, See, we'll just write it down. S is what here? See, S is S K log. P is what for metal? You can just see here. What is P? N factorial. So we'll just write it down here. N factorial by small n factorial into capital N minus small n factorial. Now we will just separate this log term here separately, n capital N factorial divided by small n factorial into capital N minus small n. So this part will solve, only this part we are going to solve first, and then we will substitute in the equation number 2. So we will go for the next term, right. So what we will do here is that now again I am just repeating the same thing here. You can just see here equilibrium concentration of Schottky defect. We started in the examination. He will ask you equilibrium concentration of Schottky defect in ionic crystal or in metals, right. For ionic crystal and metal, the same thing you have to write. Consider the ideal crystal which contains capital N number of atoms, and if EV is the free energy required to create this, we are creating a Schottky imperfection or defect. So if it is ionic, then we will take it as ES, E suffix, capital E suffix S. So this amount of energy is we are required to create a Schottky imperfection. And what is EV here? EV is the amount of energy which is required to create Schottky imperfection in metals. So that is the reason that we have written here metal as E suffix V and the ionic crystal as E suffix X. Now this is the theoretical concept. So how we can write it as mathematically, since we only know that there are capital N number of atoms and there is a small n number of Schottky atoms that can be probably that can be created. So that for that instant we'll use the permutation and combination function. So in the permutation and combination function, we'll just write it down. P is equal to capital N factorial by small n factorial into capital N minus small n factorial. Now this is about the metal, and for this is about the metal, right. So here for the ionic crystal, only the difference you will find that capital N factorial by small n factorial into a capital N minus small n factorial whole square. This is the case for ionic crystal. And why we are writing square here? Why? Because equal number of, what the definition says, equal number of the two oppositely charged ions, that means cations and anions are missing here. So therefore we'll just write it down as square. While we taking the consideration metal, we don't consider it as square here. So here only the difference is here you will find a simple value function in this particular fashion, and here if ionic crystal you will find the square. So now what we have done is that there is an ideal crystal. We have disturbed that ideal crystal arrangement. So when you disturb the ideal crystal, definitely some disorderness will be occurring inside the system. So that disorderness in the system will be known to you as entropy. This is a theoretical definition. So how we will write it is the same entropy. How we can write it in mathematical form, that can be written as S is equal to K log P. Now let us consider this is equation. See, we are considering about metal now, right? First we will just deal with the metal, then we just replace that metal with the ionic crystal, and it is very easy if you compare and do the derivation. Now this is S is equal to K log P. This is equation number 2. So K log n factorial by small n factorial n minus n factorial, right? Now this is a general what you can say formulae to calculate the probability value of the given function, right? So we'll just see, for what we are doing is I am just taking this particular term here and we'll just write this particular, we will try to simplify this particular term now. Clear everybody? So now how we are going to simplify it? So I think that you got a very clear idea regarding this, right? Now just what we'll do is that we'll do the mathematical calculation for this. Now, so while doing this mathematical calculation, you can just see that when you see the term P is equal to capital N factorial by small n factorial into n minus n factorial. So what you are going to observe here? So you can just see when we consider this as in a mathematical language, in the mathematical language we can just see that is in the form of log A divided by log B into log C. So I will just let you know that very clearly. See, I will do it very clear mathematical steps for you for such that you should have a very clear idea while doing the second expression. You will be you will not have any doubt regarding this mathematical steps that we have been involved in the first case, that is for the metal. So while doing the metal, you will come to know that how we are going to do this particular expression. So this expression will be looking in this particular fashion. So just a minute, we'll just start with this. So what we are doing here is that we'll start with log A. Let's see, we'll just start with the log A by log B into log C, right? Just a minute. You can just see this. This is the factor that we are using here. So now you can just see this starting value in this starting right now you can just see we are actually starting with this like log. This is our term that we are going to simplify, n factorial divided by small n factorial into capital N minus small n factorial. Now this resembles the fact that log of, right, it is in the form like this, right, a factorial by b factorial into c factorial, right. So how you are going to write this? Log, right, a factorial, right, minus log b factorial into c factorial. Is it clear to you? Now this can also be written as log a factorial minus log b factorial, right, plus log c factorial, right, in the brackets, right. So the next term will be log a factorial minus just take inside that minus, so what will you obtain? Minus log c factorial. Clear everybody? Now what is a here? This is very important. A means capital N, right? B is what? Small n. And C is what? This one. Clear? So now if I just compare this, what will be my step? Log, see last one, I'm talking about last one, right? This particular step minus, can I write like this? B is what, my factor? N factorial minus log of capital N minus small n factorial. Now this is the value that I obtained for what? This is the value of log P, right? And also we know that S is equal to K log P. So P S is equal to K log, this is equation number 2. Now substituting the value of log P in equation number 2, what will you obtain? S is equal to K log P. So instead of log P, what I can write here? Log n factorial, right? You can just open this bracket minus log, sorry, this is n, right? So log n factorial, right, minus log of capital N minus small n. I think that you got a very clear idea regarding this. So now what is we talk about free energy. So what is this free energy mathematically equal to? Free energy that is given by first law of thermodynamics. First law of thermodynamics. What the first law of thermodynamics says? Dynamics, right? Dynamics. What the first law says? See, according to first law, that is given by F is equal to U minus Ts. Now you got the value of S, right? S, see this there mathematically. This is equation number 3. So what the U is small n into, in the case of metal it is EV, internal energy. We talk about internal energy minus T into S. Now this is equation number 4. You can just make it as equation number 4. So U is n into Vs. Now this is what? U, right? This is U and this is Ts. This is separately, right? Now this term is separate and we'll write the F is equal to, now F will become n into EV minus T into S is what? You can write this as K and log n factorial minus log small n factorial minus log of n factorial, n minus small n factorial, right? Now this is the concept that we are going to learn in today's topic, and I think that the steps are very clear to you. So now we say at equilibrium in the expression, in the first case itself we say that at equilibrium. So what is the mathematical function that we are using for equilibrium? So that equilibrium is dou F by dou n, right, will be equal to 0. Equilibrium means constant. So the constant differentiation will be 0. Now dou F by, first we will do dou F by dou n. This is equation number 5. So what we will write here? On differentiating with respect to n. We are differentiating with respect to n. So dou F by dou n will be EV minus K into T. So what is log n factorial? Log, first of all, log n factorial. Before that we have to use which operation? We want to remove this n factorial. So how I am going to remove that n factorial? See, before going for the equilibrium concentration, right, differentiation, first of all we'll just remove this factorial term. So how I am going to remove this factorial term now? By using the mathematical operation called now see this one, this is actually log, right? This is a log. So now using which operation? Stirling approximation. So what the Stirling approximation says? Wherever you find like this log x factorial, so that can also written as x log x minus x, right? The same aspect that we are going to do here. So first we will remove this factorial term. F is equal to n into EV minus K into, I can write like this also. So n log n, clear everybody, minus n. So minus of, I will just do it very clear for you, n log n minus n, right? Now this is a big bracket, this side will simplify it. So this is what? Capital N minus small n, right? Log of capital N minus small n minus of capital N minus small n. Now this term, so when we just write this as F is equal to n into EV minus KT, right? So you can just see n log n minus n. So minus n log n, this will go inside, plus n it will become. So next this will be what? Plus n minus n log of n minus n. So what it will be? So what will be? Minus, this will be minus, minus into minus, this will be, but this will be minus n and this here plus n. So what it will be? Plus n, sorry, this is what? Minus, this will become minus, this minus n plus n, this plus n and this is minus n, get cancelled. So what is the term that will be there here? You can just see F is equal to n into EV minus KT n, sorry, see, n log n minus n. So what is remaining here? Minus n log n, minus n log n. So this minus is going inside, right? So what is the aspect that will be remaining here? So plus log of capital N minus small n. So now this is the term that has been removed from capital N small n. Let us consider this is equation number 6. Now at equilibrium, we'll just discuss this, right? At equilibrium, dou f by dou n will be equal to 0. So what it will be now? So it will be very much clear to you the next step. So dou f by dou n is equal to 0 so implies what it will be? EV minus KT. This term is 0 now, right? This entire term, right? I'm talking about this term. 0 minus, so what it will, I can write here, log of n minus n minus n log n. Can it like this? This term will be there. So if you differentiate it with respect to this, right? I am just rewriting it. N. I am just talking about n itself. Now this function I am doing here now, right? Differentiating, right? So now that will be implies EV minus KT, right? So what it will be? Log x 1 by x, right? Again we have to do minus 1 differentiation. So plus right, UV rule, right? We'll go for UV rule here. So what is remaining actually? This term is remaining, right? I just forgot this, n minus n. So this term will be remaining here. Now, okay, so this term will be cancelled here. I will talk about this term. So this complete term will be get cancelled here for this and this. This is remaining, right? This term will remain. So minus 1. So what it will be here? Log n minus n. So then again what you are going to write? Plus log of n minus n. So right. So this is the fact that we are going to write here. Again minus n into 1 by n, right? Plus log of n. So this term will be as it is. You will find that this and this get cancelled, right? You will get this as here. This is minus and okay. So this term will be here. You will find that this minus into minus will be plus here. So EV minus KT minus 1 plus 1 log of n minus n minus log of this get cancelled, right? So minus into minus, you will find that here you will be plus log n. So plus 1 and minus 1 get cancelled. EV minus KT. So what will be? Log of you can write n minus n by small n. Now can we write like this? Now this is equal to 0. This is equal to 0. So EV is equal to KT log of n capital N minus small n by small n. So this term will be like this. Now this will be EV by KT is equal to log of capital N minus small n by small n. Now implies what you can write? Exponential of EV by KT is equal to capital N minus small n by small n. Now this term will be there. I think that you had very clear idea regarding this. You got clear idea regarding the values of each and every step. So now what we are doing here is that I will just write that step again for you. So if it is not clear, again you can just see here. So here you will find that see, this value will be very clear to you. again I'm just repeat the same step now here, right? Okay, so you see, if it is not clear to you, I will write it down here again. So what we got ultimately here, EV by KT is equal to exponential of, is it right, exponential, okay, just a minute, exponential of EV by KT is equal to capital N minus small n by small n, right? Now this is the part we got before that. We will just erase it right now, this term. So what we will write here, we will erase it and then we move forward. Now what we already know that this part is very clear to you. See, capital N, if the capital N is very much greater than small n, so I can write capital N minus small n is approximated to, can be approximated to capital M. So what we'll write here, EV by, before itself log of capital N by small n, right? So can I write like this? So now exponential of EV by KT is equal to capital N by small n, right? So what is our ultimate aim? We need to get the value of small n, right? So how will I get the small n value? So I just make this denominator to numerator. So how I can make it? See, if I write like this, capital N by small n by capital N is equal to, can be rewrite as minus EV by KT. So small n value what I got, capital N exponential of, right, minus EV by KT, right? So now this is the mathematical expression. Still we cannot further simplify it. So this is a mathematical expression for finding out the Schottky effect in metals, right? So what will be the change you will find in ionic crystal? So this is for we talk about metal. So what is the basic difference you will find in the ionic crystal is small n. You can just refer the notes for this. If you have any doubt, again I will repeat this. Instead of EV you will get EVS and 2KT you will get, right? So like this, this is what I think 7th one. Now this is here this is for the Schottky effect for ionic crystal. So I think that you got a very clear idea regarding this V minus EV by KT. So only the difference you will find here for ionic crystal is, instead of E suffix V you will get minus ES by 2KT. Small n is equal to capital N exponential of minus ES by 2KT. This is for metal and this is for the ionic crystal. See, so the part is very easy for you to understand. See, what we are doing is here is that we just removing the factorial term by using the Stirling approximation. So in this particular part it should be very clear to you that we are using the what you can say. See, what we are doing here is that we are using the two important aspect here. First of all, we are using in the mathematical functions first UV rule, right? So UV rule we are used here. We are using UV rule, and also we have used here the second important aspect is Stirling approximation to remove the factorial term. So for removing the factorial term and the mathematical function, the other function that we are using here is the Stirling approximation and UV method. So if you are clear with the Stirling approximation, UV method, and the third important aspect is probability concept. So these two concepts are three important parameters which are very necessary to understand. Either it may be Schottky effect for ionic crystal or it may be for metal.